right, so we already have this geoangle here. We have some stuff here copied and pasted. So I guess let's just paste that in here. So that's going to do the packed transform thing. Of course, we don't want to do this completely. Let's remove this mix value that we have, or let's set it to a specific value, to be honest. Let's try like 0.06 or something. So we're going to mix with this 0.06 value. But we're only going to do it if the pieces are going to get within a certain distance. So let's grab our stuff that we have here. So let's I guess load these points. Vector P1. And let's go into inputs. We need myself and we need first context geometry. So these will actually work. Right, so let's compute distance. So float distance equals distance from P1 to P2. So we have a distance. And let's say that if distance is below 1, then we're going to execute this little thing. Right, so let's just play and see what it's going to do. So you can see it's somewhat doing some stuff. Let's increase maybe our mix value a little bit, so it's going to be a little bit more pronounced. And let's make our sequence a little bit longer as well. So we can keep going a little bit. So you can see it sort of works, but it's getting a little bit unstable. So this is where the stuff comes in, where I mentioned, we probably need to sort of deactivate these pieces after a certain while so they can sort of blend in position, right? So let's start adding sort of a sort of an attribute that we can use to sort of decrease it or to sort of deactivate it if certain variables are met. All right, so another thing that we probably need to do is we don't want to do this mixing thing completely in the beginning, right? So, and like we have with the pop attract here, we only activate it after a certain frame. There's no activation on a wrangle. Let me just, by the way, delete these other two wrangles that we have. So we can make our own sort of activation. So how do we do that? It's pretty simple, actually. So let's say integer I, for example, equals channel integer. Let's call it activate, something like that. Right, then we're going to say if I equals 1, then we're going to do this entire block here. So we're only going to run it if it's 1. So they create a slider. So if it's 0, let's play. Then you can see nothing is happening. If it's 1, then it is going to do the thing. So, and we can, for example, link this up to our activation on our pop attract. So we just say paste relative references. So you can see now sort of do this thing. So yeah, you can see it's still a little bit unstable. It's like sort of, let me, by the way, just make it like an environment light or something. So we have something to, so it's a little bit easier to see. Yeah, so now we have some highlights at least. Let's do these. Let's make this black, not completely black. So it's just easier to, to look at. So you can see it's quite unstable, right? It's like it's trying to sort of stay in position, do its things. So yeah, let's do some checks and balances to sort of get rid of this instability that we have here. Let me just few second inputs, right? So what we're going to do is we're going to say that pieces can ignore a collision. So they can ignore, for example, these pieces that they're bouncing up against now, if they have been trying for a certain amount of time. So how can we do that? Well, we already have an incrementing variable here, right? A mix value. Let's, by the way, decrease it maybe a little bit so it doesn't assemble as fast. So it should still be pretty sort of straightforward. What we're going to do is we're going to also write it out maybe as an attribute. Because remember, stuff if you just type like this, for example, float and mix, is not gonna like if I were to do this, so like plus equals 1, whatever, it's not gonna add it onto it. So we need to write it out as an attribute, else it cannot increment on itself. So let's say f at mix plus equals mix. Now it will create an attribute called mix, and it will add mix onto there. Right. So let's have a look on our thing here. Select this on the right, and let's check our attribute mix. It's not there yet, so now it is there. Right, so let's play. You can see in the beginning it's 0, but when they get close enough, you can see mix will start incrementing. And what we could do is we could now use mix to set an additional statement. For example, maybe we should, by the way, type some comments here in a little bit. So I'm going to do that. So maybe we can already do that now. Set mix value, probably to make it sort of a little bit clearer. Blend transformation matrix. Measure distance between point and rest. All right, so a little bit more clear. Let's say deactivate stuff. All right. So let's do another thing in the deactivate stuff part, sort of. So let's say, for example, that if mix is high enough. So let's say if mix is above 5, and we're going to put them in a group. So group, let's call it ignore. It's going to be 1. So if they're going to be in the group, so we can check these groups. So it's already on, like group ignore. So after a while, you can see the group ignore will be 1. What we can use is we can use this with pop collision ignore. So this will allow stuff to ignore collisions. So if I put my ignore group in here, if I now press play, you can see we have a perfectly assembled box. So the blue stuff is no longer there. So we fixed the entire issue. All right, so let's also do this explosive force that I have in my original. So let's do force. Let's say $F below frame 3. So that's going to evaluate to 1 on the first couple of frames. And let's say times 100 or something. Maybe a little bit more higher, 70. Right, so now you can see it sort of explodes a little bit. And then they're going to be pulled towards this thing. Probably want to maybe this, like, lower the noise on that thing. I probably want to decrease the drag on the ground. So the friction, probably do 0 friction, because they're sort of starting, some like got stuck on the ground, which we probably don't want. So now you can see them sort of assembling together. And maybe what we also want to do is sort of increase the radius of when they're sort of allowed to start blending to the position. to increase with the age. So maybe we should say distance plus at age divided by 3 or something. Distance below 1 plus age divided by 3, right? So let's see what that is going to do. So now that range, like you remember that we did with the color stuff, that's going to decrease the older they get. So now you can see now we fixed the issue as well. So you can you can program a whole bunch of behavior this way. Let me just go to this thing. So yeah, essentially that's how it sort of works with this boxy thing. So you can see it looks pretty cool. Now let's get over a couple of extra steps that we need to do in order to make this work for other geometry. So because this works on box. And this is going to be a challenge. So because you should theoretically already know how to do this, let me just show you an issue that we're going to run into, and then I'm going to give you a little challenge to fix it for yourself before I'm going to explain it. So let's for example do a torus. Let's just fracture a little. Let's fracture our torus. So let's do something like this. So offset, scatter a couple of points in it for another fracture. For another fracture. All right, there we go. All right, let's do a switch. No, not sweep. Switch. And let's switch from our box to our torus. All right, so I'm going to show you what the issue is going to be, because it is going to work, but there's going to be some issues. And then I challenge you to try to fix this. So you can see it is working. Oh, it's self-assembling, super cool. Yeah, row. But let me create some environment light, by the way, so we have something better to look at. Let's hide our other object. All right, so you can see there's a little bit of an issue here. So what do you think this issue is? And how do you solve it? I'll give you a couple of seconds to pause the video, and I'm gonna like challenge you to try to figure out how you can sort of fix this. So I'm gonna give you a couple of seconds. 3, 2, 1, and all right. So essentially, you should probably already know this, and I've actually already had it accidentally teased in my recording. But like I mentioned, these intrinsics you have intrinsics in these things have packed intrinsics, also for the pivot. So the pivot. And the problem here is that these intrinsics here, well, after it sort of does the assembling, they're not really lining up. It's like it tries to sort of put it in the center, and it's just not the same anymore as before we did the packing thing. So the pivots don't really line up from the original here and the one in our DOP network, which is fine, but we need to account for that. So that's pretty simple. We can do that just in our little wrangle here. So we just need to load our pivot. So we can just do that. Let's say vector pivot. We're going to say prim intrinsic. So again, you can open the help file on this if you want. Show intrinsic. So what we want to do, from first input, the intrinsic name, pivot, and for every prim number. Right. Oh, we need to do that for the first input, by the way, because we want to grab it from the rest input, right? From the first context geometry. So that's going to be, where is it? So that's going to be this thing. So the rest position. And And then what we're going to do is we're going to set it. So set prim intrinsic 0 pivot prim num. Let's open up the help file, by the way. So geo handle name prim num. It's a primitive number. The value is pivot, and what we want to do, we want to set it. Boop. You already see it fixed. So yeah, if we play now, probably also one thing that we want to do is maybe introduce a little bit of drag here, because these pieces keep flinging away quite a bit. So maybe let's do a little bit of drag. But yeah, I mean, you can see now it also works with a torus. And I could do another thing. I could do a pig. Let's remove the shader. Let's plug a pig in. Oh, and the viewport bug is back. So let's make a new viewport. Let's reset this. So the volume sample is messing up a little bit there with the colors, but I think it should be fine. So yeah, you can see that this works. Again, this should also work with collision objects on the ground. So let me just make a collision object on the ground here. Let's make it a static object. Oh, and let's make it concave. And let's merge our ground plane into that thing and move this around so that they're all merged into this thing. Gonna use concave. Concave is quite slow, so don't generally use that, but for something like this it's fine. So let's press play. And you can see this works fine even with our collision object, which was what I explained was an issue in the beginning with the other setup. So yeah, let's do it again with our boxes. So yeah, pretty cool setup, right? So yeah, a little might be a little tricky if you have never worked with some of this stuff like pack transforms and yeah, intrinsics and stuff like that. But I think it's probably pretty interesting. Right. So one more thing that we probably want to do is let's go out of here. Let's maybe first disable our torus for now, so we just have them drop on the ground. Maybe I am gonna add a little bit of friction, by the way, to our ground, because it's a little bit too much. But let's go out of here and let's make a file cache. Let's cache it out. Call it widgets. Make sure your $job is set. So again, this is my caching preset thing. If you want to know more about these presets, go check out my VFX folder structure video, which you can find on my website or my YouTube channel. I have a whole bunch of these things. Anyway, let's save this out. So we have our widgets assembly here. And what I want to do is I want to add a little bit more of a sort of just like a little bit more sort of jiggliness to it. We're going to use chops for that. It's kind of like a lot of effector stuff in Cinema 4D that you have with MoGraph. In Houdini, that's called chops. I'm not too familiar with chops. I use it for stuff like that. I'm trying to show you, so which is wiggly stuff. But For stuff like that, it's pretty cool. Aside from that, it's like it works completely different from a lot of the stuff in Houdini, so I'm not too familiar with it. There's some cool stuff on it on Tokeru. So if you don't know Tokeru, then it's about how high time you find out what Tokeru is, because it's amazing. So it's a blog here about about Houdini, and it has so much stuff. But there's also stuff about chops here that I should probably dive into. But there's more of these areas, like I don't use cops that much either. Anyway, we're gonna use it a little bit. So we're gonna in chops, we're just gonna do something very simple. I'm gonna make a channel. I'm gonna do a channel over here. I'm gonna make a chop network. And we're gonna go into this chop network. And we're gonna say geometry. So we're gonna load in geometry. We're gonna drag in our chops. We're gonna say it is animated. I'm gonna make a null. I'm gonna give it a name called out. I'm gonna reference that in our thing here. And again, we're gonna say animated. So if we now check that, nothing really should happen still. But what we can do now is put chops in between here. So for example, jiggle. So you can see if I put jiggle, you can see it sort of modulates what's already there. But you can see if I'm going to play this, you can see it's gonna do some additional jiggly here. So I'm actually not too sure how to make chops work with attributes. So what I just did is I keyed it in. So I just put limit to that, and then I'm gonna put it from 0, so they at least are not jiggly in the beginning. And then we add in a little bit of jiggliness. So just a very tiny sort of extra thing. And then we're left with a sort of cool little cube thing. So yeah, we could you could do that. And yeah, again, this also just works with rotating rest position like we have here. So yeah, I guess let's just put an output here. Right, so one more thing actually before we get into the other stuff that we need to do. So I forgot one thing to cover in the previous part. So I've already recorded most of the other chapters for this course. And then when we were doing lighting and shading, I suddenly noticed that, oh wait, I actually need more boxes. And I actually hadn't simmed the real high-end or the high-res version. Because if you look at my actual render here, is that I have more layers. I have like the inner white one, then I have the orange ones, and I have blue ones, and then I have black ones. And if you have a look here, we're a layer short here. So we have white, we have blue, and we have black. So actually what we want to do here before we move this to another project is put the division of the point separation on the points from volume to 0.15. And then 0.15 should give you, so let me just do it as like version 3 because I already have some other stuff saved out. So this should give you more points. Just keep in mind that if we're further in the chapters after this, we'll have a little bit less points again. But so just so you know that's why there's not going to be that many. But like you can see now we do have, we have blue here. Could I guess change the color up a little bit more even. See if we can yeah, so now we can see we have this extra color layer, so we could do red, like we have red, orange, blue. So we have the full thing. Anyway, without further ado, now let's set up the actual project. So remember, after this, I'm gonna fade to black, come back, and then we'll have the one with less boxes again. So just this is just a quick fix. Anyway, let's continue.